All right, Honors Algebra 2 and Algebra 2. Here we are at the start of video number 2 for your 4143 game plan. This is the bottom of page 20, and honestly, probably one we have already discussed in class, a lot of these questions. So, looking at the graph of, we did not graph this yet, but the x-intercept is when y is 0. So we will factor, and if we had looked at the graph, we would have gotten two x-intercepts at -2 and 4. All right, so what we're going to do, here's a little factoring review. What multiplies to 21? It differs by 4. That is a -7 and a +3. Remember the middle term. The sign of the middle term is going to match the biggest factor, so -7 plus 3. Here you got a 0x in the middle, so it's really like x squared plus 0x minus 64. So what multiplies to 64 differs by 0, 8 and 8. One's negative, one's positive. Because when you combine them, you get 0 when you add them, and when you multiply, you get a -64. 4 is a little different. What do these two terms have in common? They have an x in common. So when you factor, you're dividing the x away. You had two x's, take one away, minus 10. All right, number 6 here, again, the same thing like 4. What do these two terms have in common? A 6 and an x. Divide 12 by 6, you get 2. Divide 18 by 6, you get 3. All right. Let's flip to the next page. Now we're solving. Okay, so we did a lot of these in class. Folks, it's not the, first off, we're going to, we have the 0 product property for the cover-up method, not the 17 product property. So what we're going to do is we're going to subtract, just like on 7 here, we're going to subtract 17 from both sides. Now, we can take square roots. We'll talk about that later. So then I get x squared minus 4 equals 0. That's what I need, equals 0. What multiplies to 4 differs by 0. That's the middle term, +2, -2. There we go. Here's number 4. What multiplies 28 differs by 3, -7, +4. Then we have the cover-up method. X minus 7 is equal to 0. Then x plus 4 is equal to 0. And that's how I get my two solutions. Like on the previous one, it was -2 and +2 for my two solutions. Now on 8, we're going to factor out the 12. These are both multiples of 12 and the x that these have in common. Factor out the 12x, you're left with 12x times x minus 9 equals 0. Cover-up method, 12x equals 0. X would be 0. Cover-up method, x minus 9 equals 0. X would have to be 9. Now, if you weren't with us in class, we're going to move the 72 over, plus 72. Then we're going to divide. Then we're going to factor. And you actually just get one solution here, x equals 6. All right, and we are moving on. Solve by factoring. Again, it can't equal 30. It's got to equal 0. So I'm going to move the 30 over. It's positive on the right. It's negative on the left. What multiplies to 30 differs by 1, 6 and 5. You get x is 6. X is a -5. On 3, there's no constant here, so you don't ask yourself what multiplies to 0 differs by 15. Instead, you factor out the 5 and the x these two have in common. Divide both by 5 and an x. You're left with 5x equals 0. X minus 3 equals 0. All right. Write a quadratic equation with the given roots. This time I'm telling you x is a -7 and x equals 5. That means that going backwards, if you move -7 over and the 5 over, x plus 7 would equal 0. X minus 5 would equal 0. All right. Just going backwards, if we did the cover-up method, we would get those two solutions. So now I'm going to get rid of the equals 0 part. I'm just going to FOIL here. X squared minus 5x plus 7x minus 35. Combine the like terms, the middle terms there. We get x squared plus 2x minus 35 is my quadratic. Okay, so take a look at 3 here. Factoring by grouping is really Well, notice it says put in second video, so let's just get at it. Let's just do these, okay? Factor each. So what we have here is we're going to factor by grouping. We're going to group these first two terms together. What do they have in common? They just have a single x that they both share. So x on the outside, followed by 3x plus 2y. I'm taking the x away. Always bring down that same sign. What do these two have in common? A 5, divide both by 5, then you're left with 2y plus 3x. Now, I know this is out of order, but positive 3x, positive 2y, positive 3x, positive 2y, those are the same two terms. So those outsiders come together in one parenthesis, and then the 3x plus 2y in another. And here's why. Take a look at this 3x plus 2y. Okay, so the 3x plus 2y is clearly being multiplied by x. 3x plus 2y, both going to x, and then they're both going to 5 like they would here. So, going backwards there, we can see how those are the two factors. So what do they have in common? They both have an x in common, and they are multiples. 32 and 12 are both multiples of 4. Divide them both by 4. 32 divided by 4 is 8. You took away the x, you're left with a plus. 12 divided by 4 is 3. You took away the x, you got b minus this time. Be careful, you're subtracting. What do 48 and 18 have in common? Uh-oh. This is not an issue. I just can't divide. It's 6. All right, and then 6y. You're doing a negative divided by a negative, so you're left with 8. You took away the y, there's the a. A negative divided by a negative is a positive. 18 divided by 6 is 3. You took away the y, you're left with b. These have to be the exact same, and they could be out of order like they were up here. It's got to be a positive 3y and a positive 8a and a positive 3b. Now, 4x minus 6y could technically be factored better because both of those terms are multiples of 2. So you should really, again, this is more of a chapter 5 question. I can factor out the 2 that they have in common. So honors algebra 2, definitely write this. We'll get to that in chapter 5. All right, number 3. Let's talk about number 3. What's 18 and 24? You can factor out to these 6. Both multiples of 6. They both have an a. 18 divided by 6 is 3. Negative 24 divided by 6 is a negative 4. Take away the a, you're left with a y plus 48 and 16. Divided both by 16, you're left with 3. Negative 64 divided by 16 is a minus 4. Okay, those guys go on the outside. So again, like last time, then the 3 minus 4y goes in its own parenthesis. Like last time, we could divide both those terms by 2. And we could write this better. But this is a fine answer right here for right now. All right, so number 4 here. I know that x equals 8 and x equals negative 3/5. On the previous page, you had a few of these. So I'm going to not do that. I'm going to move the 8 over. I'm going to move the negative 3/5 over. That's a problem. I don't want to multiply by x plus 3/5. So I'm going to multiply everything by 5 here. And I could have done that originally. If I multiply everything by 5 here, I now have 5x plus 3. And that's what goes in the parenthesis. And then I first, outer, inner, last. All right. On this next page, page 24, let's do number 3 here. So move the 16 over and then divide everything by 2. Now we can do easy factoring. Multiplies the 8, differs by 2. X minus 4, x plus 2 is 0. Cover up method, x minus 4 is 0. X plus 2 is 0. Those are my 2 nice solutions. All right, the next page, page 26, is one we should have done. It's just foiling, all right? So I'm just going to give you, first off, let's get this right. Here's number 2, first, outer, inner, last. All right, here's number 6, first, outer, inner, last. and then pause this when you ever need to. Here's 13. Just write it twice. Again, practice that trick, folks. In fact, Honors Algebra 2, look at this. Here's a trick. So x squared, the inner product, you're going to have to multiply x by 9 twice. So you take that inner product, 9x, and you double it. And then you take 9 and you square it. So we can go straight to that answer. Again, we know that we're going to square 3x. 3x times 3x. That inner product of 3x times 2, 3x times 2, 3x times 2, we can just double it. So we can double 6x, and then we're going to square 2. And on 15, first, outer, inner, last, combine those like terms. All right. Next page, page 27, we are factoring. Again, I made a mistake on this. What multiplies 28 adds to 11, make that 11x, not 7. That is x plus 7. This whole page is x plus a number times x plus a number. All right. What multiplies to 7 and adds to a positive 8? Both factors got to be positive. 7 and 1. On 8, what multiplies to 10 adds to 7? 12, what multiplies to 1 adds to 2? You can write it as x plus 1 twice. On 2, what multiplies 12 adds to a negative 7, x minus 4, x minus 3. Multiplies to 9 adds to a negative 10, x minus 9, x minus 1. Multiplies to 45 adds to a negative 14, x minus 9, x minus 5. On 2, what multiplies to 30 differs, because we have a negative, differs by 1. It'd be a 6 and a 5. The middle term is positive, so 6 has got to be positive. X plus 6x minus 5. On 5, what multiplies to 18 differs by a positive 3. Or differs by 3 first. 6 and 3 multiply to 18, and they have a difference of 3. Middle term is positive, so your bigger factor is positive again. Here is 10 and 11. Well, multiplies 16 differs by 6, 8, and 2. Middle term is positive. It's positive 8, negative 2. Well, multiplies 28 differs by 3. Middle term is negative this time. 7 and 4. 7 is negative. And then 13. What multiplies to 70 differs by 3. X minus 10, x plus 7. All right. Here we got guess and check. So this is what we've talked about in Honors Algebra 2 a lot. We can't ask ourselves what multiplies 7 differs by 13. No two numbers do that. And that's because this 2x squared is a little different than the previous page. Previous page, when we had x squared, it had to be x times x. Well, with the 2x squared, there's only one way to get 2x squared, and it's if you multiply a 2x times a single x. There's only one way to get 7. It's 7 and 1. So you either put the 7 there or the 1 there. Here's the right answer. Here's how you check. First off, you got 14x, and you got a single x. Is there a way for one of the factors to be negative, because you have a negative constant, for 14x and 1x to give you 13x? And there is. If you do 14x minus x, so this is a negative 1, and that's a positive 7. Guess and check. Okay, on 6, there's only one way to get 3x squared. It's a 3x and an x, so you put that there first. There's only one way to get 5 as a factor. It's 5 and 1. If you put a 5 here and a 1 there, again, you just do this part of 4, 15, and then a single x. Is there a way to get 15 and 1x? 15x and 1x to be 14x? There is. You make that a minus x. So this is a negative 1. That's a plus 5. Again, let's practice one here. So look at number 4. There's only one way to get 3x squared. It would have to be a 3x and an x. Negative constant means one of my terms negative is and one of them is positive. So if, factors of 6, 6 and 1, 3 and 2. Here's what I guess. I get 9x. Then I get 2x. Is there a way for 9x and 2x with one of them being negative to get a negative 7x? And there is. If that's negative and that's positive, that gives you a negative 7x. So that would be a negative 3, and that would be a positive 2. And we have foiled it. We have not FOILed it, we have factored it. All right. Take a look at page 32 here. Write each in standard form. That's just ax squared plus bx plus c. I multiplied the -4 through. I distributed that, and then I FOILed it. All right, so take a look at that. 10 through 13 factor each. What multiplies 14 differs by 4. There we go. -9 plus 5. First off, factor out the 4 they have in common. And this is a difference of two perfect squares. What multiplies the 9 differs by 0. X plus 3, x minus 3. On 13, what do they have in common? They have a 5x in common. Factor out the 5x. 5 divided by 5 is 1. You had 2 x's. You took 1 away. You have a single x. Minus 40 divided by 5 is 8. Everybody can get rid of 14 here. That's in the next game plan. We'll do a lot of completing by square, completing the square. All right, then the very last page here, Honors Algebra 2, we did this in class. An object is launched it's 19.6 meters per second from a 58.8 meter tall platform. The equation for the object's heights at time t seconds after launch is that. It's very true. We do a lot with that in calculus. When does it hit the ground? It hits the ground when the height is 0. When the height is 0. So instead of writing h of t, we write 0 equals that. Then, man, we hope we can divide everything by -4.9, and we can. Divide all those three terms by -4.9. You're left with positive t squared minus 4t minus 12, which can factor. Cover-up method gives me those two answers. And the only true answer is 6. There's no time of -2 seconds. The object's height, that's the vertex. And in Honors Algebra 2, we started graphing those. The vertex is -b over 2a. Your b value is 19t, so the opposite of it is a -19. Your b value is 19.6. The opposite of that is a -19.6. Divided by 2 times a. It takes 2 seconds to reach the maximum height. You plug 2 in for t in the original equation. Just evaluate that. Guesses here. Was okay. Is it 58.8? Anyway, it's not 58. I think it's 78.4. Anyway, you have calculators. Use a rocket is launched from the top of a cliff which is 80 feet above the sea. The height of the rockets above the sea is that. Now we're talking about feet, so that's why it changes to the -16 t squared. Again, we'll talk about more about this in calculus and why it's -4.9 t squared and why it's -16.2 t squared. The middle value, is the initial velocity, and that's the initial height. We're going to change the question. What's the maximum height obtained? All right, so that is the vertex, -b over 2a. The b value is 120, so the opposite is -120 over 2 times -16. 3.75 seconds to reach its maximum height, and you plug 3.75 in for t. Definitely use your calculator for that. And you can get rid of, first off, change that question to what's the max height, and you can get rid of that bottom question. All right, so this is a long video, and honestly, especially Honors Algebra 2, you could be 90% of the way done after the second video. Algebra 2, you got a lot of answers here. This is Yak Math Videos signing out.